So welcome to Seen and Solved. Today's episode is Clean Before You Shine, Mastering Pretreatment and Electroplating. We'll explore why surface preparation is critical to achieving high-quality, durable plated finishes, the common challenges plating shops face, and how advances in chemistry and processes can improve performance, reduce rejects, and promote sustainability. Our guest is Bukola Adeyemi, a new application specialist with solid experience in technical and sales engineering across the semiconductor, plating, manufacturing, and precious metal industries. We'll be right back.
You're listening to the Seen and Solved podcast, brought to you by Hubbard-Hall. Better results, less chemistry.
So, Bukola, let's talk about pretreatment. It's such a vital and often overlooked step in the finishing process. Why is it, especially in cleaning, why is it so critical to have proper pretreatment in the electroplating process?
Thank you, Tim. So, pretreatment is the foundation of all plating process, right? I see pretreatment, I like to compare pretreatment as, painting a wall. You wouldn't want to paint a wall, on a wall that is, has grease, mud, dirt. You want to do your prep, you want to, pulp, like scrape, apply your coats, base, and everything before you actually, put the fine coat on it. So same way I see pretreatment, like comparing to painting a wall. Especially in plating, you want to make sure that, you have a clean base metal. You want to make sure that your parts are free of oil, smudge. You want to make sure that, you have the right adhesion. You want the proper adhesion and proper plating concentration to achieve, the success you want concerning whatever you're working on. So basically, pretreatment is our foundation and a vital fundamental foundation of plating. So without pretreatment, you're basically setting yourself up for a plating failure. In other words, so you might have the best chemistry, but if you don't have the proper and the adequate pretreatment, you're as well as starting off with no good.
I agree with you, and I find that with a lot of people who have issues later on with adhesion or other type of things. It started in the pretreatment. But what are some common cleaning and pretreatment mistakes that shops make?
So one of them I see every time I go out is rushing the process, right? Most shop, they just want to get it cleaned and just dive right into the plating bath. Over time, I see that plating shops focus more on the actual plating bath, like nickel, copper bath, than, the pretreatment. Overlooking the fact that the pretreatment is the number one thing that you need to get right before you can have the other chemistry baths to, function well. So rushing the process or skipping, one cleaning step is one thing that most plating shops, overlook. Another one would be using a one-size-fits-all, So they would use one cleaning or one pretreatment for different type of substrate or base metal. Unlike when, we have one base metal that has, a different type of either soul clean, ultrasonic, but they just use one size fits all. And, this is one problem that they face. The other one would be, inadequate bath control or poor bath concentration. So, like I said, the focus is more on the plated bath than the actual, you can't skip a step. Proper rinsing is another one. So right. In between your steps, in between your pretreatment, you have to have proper rinsing step and poor bath control, not having the right concentration, not replenishing on time. These are the things that most shop overlook. And when, they get down to the problem, they focus is the plating mat. And I'm like, no, we have to start from the scratch. Let's look at the cleaning. Let's look at the pretreatment. Are you skipping any part before we, because most of the time it's cleaning. When they fix the cleaning, then the rest is history.
So let me ask you then, just let me state the obvious with you. If it isn't done right, what's going to happen? Like you said, is it going to be, you're going to have flaws, you have defects, things like that? That's what's going to happen if they skip a proper pretreatment?
Yes, for sure. One of them is, adhesion failure. Another one, they could have pitting on the pad, they could have blistering. And when you look at this, sometimes they try to not stop production because, they want to keep production rolling and to have a downtime. But if they don't do the adequate thing, that's going to eventually happen because, when they're making more scraps, more defects, then they got to stop production at some point and wait for someone to come in and help them fix the problem. Sometimes even contaminating the chemistry as well happens in the long run. And at the end of the day, they eventually have to make a new batch or, add more than they actually need to do. So these are the things that, happen in the long run of, trying to overlook or overstep. You just, there's something that I used to work with before. We call it pre-flights. So there's a mechanical pre-flight, there's a chemical pre-flight. This has to be done properly before production kicks off. So this is basically saying, hey, we have our mechanical in check, everything, the pipes are good, these are good, everything that needs to running before production are in check. Then we go to the chemical profile and make sure, testing is done, right concentrations, specifications are in check before production. So this has helped us eradicate. It's like doing the root cause of the problem, like trying to eradicate the problem if it arises. So say production is going on and then, they were having defects or they were having rejects. The first thing we can do is, go through the specification, go through the pre-flights, see, was this checked today? Was everything okay? Was signed off of this? Was the proper, the foundation done before production kicks off?
Let's talk about best practices. So that's what you're talking about. Pre-flight is really having the best practices and putting those in place. So let's start off. Walk me through what are the key stages of the typical cleaning process before plating? Walk me through that first.
The way I say there are 3 steps. We have the mechanical step, we have the chemical step, and also we have the activation. So you need to clean, and before you activate, then before you put your actual metal onto the part. So the mechanical step, I'd say it under 2. One is the equipment, and the other is ensuring that you have the proper equipment in place or the proper kickstart of the pre-flight in place. So in terms of chemical, and also we could consider the mechanical as also the base metal or the substrate preparation, because before you plate, you want to make sure your parts are oil-free, smudge-free, fingerprint-free, and things like that. So that would also be considered a mechanical step under the parts, and also equipment mechanical under making sure, there's no leak in your pipes, your agitation are working right, and all this. Yeah. So once that is checked, then we can go into the chemical, making sure that your batch is in the right concentration in terms of the makeup, your composition are right, the quality specifications are in check, they are in the specified limits, and then acid activation. So based on the substrate that you're working with, some require less aggressive than the other. Then, depending on what you want to work with, then you can decide if you want to do a sulfuric or hydrochloric acid activation at the point. So these are the steps, in getting this ready. And also you want to ensure there's proper rinsing in between each of the steps, because you want to avoid dragging of chemicals or, soap to the activation and all that stuff. So there has to be proper rinsing in between the steps.
How does a shop, say they get everything set up, how do they know when it's time to adjust or replace their cleaning process? Is there telltale signs for that?
So I like to say too, is like I mentioned earlier, there has to be quality control in check, because you're working with chemicals. You have to be sure you're working within the specified limits of operation. Right. So these are one part that I see, and that's where the chemical pre-flight comes in. Say, every morning you have to check your chemical concentration. There are testers, there are ways you could check to make sure that, okay, this batch is still functional. The other way would be when you start having problems, when you're having, when the metals are not sticking to the part, when you're having poor adhesion, when you're having defects, or visually, the parts are not plating well, or if quality is rejecting the part, then this is when you can tell that, okay, it's time to change the bat or it's time to replenish. There are ways you could prevent changing. If you replenish, often by checking, testing. If you're low, if you're high, you know how to replenish. You either, adding more water or you're adding more chemicals to maintain that balance. This could prevent, changing a whole bat on time. And, when you see that, okay, there's too much oil on the surface, because sometimes you can tell visually when there's too much oil on the surface of the bat, it's time to change. So these are ways you could prevent. But most clinicians, They just continue until the whole bat crashes. And then they try to like, oh, how can we fix this? But then there are ways you could prevent this before, we actually get into this stage.
Well, let me ask you about rinsing and water quality. Very important. How is that play into the quality of the water, the quality of the rinsing? How does that play into the effectiveness of the surface prep then?
So the way the water plays is, like I said, you want to make sure there's adequate rinsing in between the parts. And the water you're working with also plays a vital role. If the water level or the pH of the water is either too high or too low, depending on what you're working with, this can also impact the bat, because while you're raising, you're dragging, it alters the chemistry of the other bat you're working with. So if you're working with an acidic bat, say you're doing an acid activation and you're dragging in water with either high pH or low, depending on, what the pH is, acidic water, there's DI water, depending on what you're working with. If dragging in occurs at this point, you can alter the chemistry of what you're working at the time, and this also could prevent or could impact, how operation works, or how the chemical sticks on the parts. So having the right amount and having the right pH of water is very, very crucial in production in plating. You don't want to be too high, you don't want to be too low.
You mentioned some of those. Are there residues, contaminants that tend to cause the most trouble that you've seen?
They do, and in some situations, there are filters in place. There are filters. There's a way that you can put filters in your bat, so this kind of like takes out all the contaminants and help reduce, how the bat builds up in terms of contamination or residues. So all of these are things that need to be in place. And again, while you're bringing in base metal, it has smudge, it had holes, it had so many leftover residues on the parts. As you're cleaning, you're dropping off some contaminants in the soak clean by default. So going through another rinsing process, going through activation, it needs to take some certain steps of cleaning, rinsing, and activation before you can get all that out, before it actually gets into the plating bat itself. So in most cases, we really advise that, you have filters in your bat that can help while it's running, it's taking out all this contaminant, taking out all these residues while, leaving your bats to have a longer life of operation, rather than just having it as pure as it is and just letting everything sit down, so that when you're running other parts while agitation is going, you're also introducing all these residues back on the path. Because it's like you're repeating the circle. So when you have a filter in place, it kind of like takes out all the residues and stuff and still maintaining your bat purity as well.
A lot of what you're talking about is grading practices and theories and everything. Operator training, I think, is really very important. So how important do you feel operator training is to make sure that you have a very good cleaning and pretreatment system set up?
So for me, I think we need to let operators understand the why as to this is important. And like I mentioned earlier, their focus is mostly on the metal, on the bat metal itself, and they tend to oversee, like, just clean it, rinse, and they're more concerned about the plating bats itself, like nickel bat, copper bat, tin, and the rest. Now, when you're making them understand, there's a reason why this is important. It's a simple step, but it can never be overlooked. You can have the right amount of chemistry, you can have the best chemistry, but if you don't have the proper clean, if you don't have the right amount of cleaning practice and cleaning process in place, the chemistry is not going to do justice to the part. So training them and letting them understand that, you could avoid this trouble of shutting down or having a production downtime if you do this from the beginning. So letting them understand the importance of having a clean part before it actually goes into the plating bat metal is a way of letting them understand that, this needs to be done to enhance a smooth operation. But if we skip this process or if we rush this process, the end is not what we're trying to get. Like, it's gonna, bring us back to where we are. So having them understand the reason why cleaning is really, really important. And like I said, I use a painting as an example. You don't just want to start painting a wall without doing the proper thing. So relating to a real life situation and understanding, like, you need to have a clean part to have a clean operation, a clean chemistry. So, this is one way that, try to let them understand the importance of this.
There's been a lot of regulatory changes about cleaning, especially cleaning. So how do shops, balance that, where they want to get really good cleaning and pretreatment with the regulatory issues that they face? How do they work that out, do you think?
For most things that I see, with the changes and everything going on, and of course, with the water consumption, this cleaning shop are trying to reduce their water usage. So with the new chemistries, new innovations coming on, I think they are more than happy to, welcome this changes and new innovations coming. Because again, if they have good chemistry, they want to use less. They want to have better result. They want to use less chemistry. And, with new automations coming on, they enhancing their process. They're reviewing their operational process, as well as, with the new chemistries, new innovations coming on. So it's happy for everybody. Less chemistry, better result, less usage of water consumption, and less smudge making, less residue making. So they're also looking forward to what can we do, how can we continually improve this process without using much, but still in compliance with the regulatory system, and as well as consuming less water, and something good for the environment as well.
I had a shop one time tell me the most expensive chemical he uses is water, which took me a while to think about it, right? But it's expensive, and you got to treat it, and you got to treat it right, and to export it out. But where do you see this in the next 5 or 10 years? Any changes coming up in the pretreatment technology, or where do you see this coming up in the coming years?
There's new automation system going on every day. There's new changes going on every day. So I feel like, I foresee that in the next, 5 to 10 years, cleaning shop will probably have upgraded in terms of even automation, their automation system, something that would work well with the new innovation at the time, or something that's already brewing. So something that would work well with how they operate, and also enhance their operation. Is not just for we're doing it because of the future of cleaning, but it's a win-win for everybody. The less complicated your process are, the happier you are. You're using less time in production. You're making more production, less time consumption, more production, less water usage, less chemistry usage, and then better results. So these are the things that they also look at, because of course they don't want to spend. You go to most clothing shop, one thing they say is, "Oh, we're spending more time in producing this. What can you do? How can you help us that we spend less time and we make more production?" So all of these things are something that these are some of the questions that we come across when we're on the field. That how can we reduce them? How can we reduce, operation time of this? I spend 1 hour, making like this job. Can you help? What do you have that can help me, reduce to like 30 minutes, 25 minutes? So they even clinicians are looking for innovations. They're looking for something that will help them spend less on, the time consumption of, and again, you think about it, the electricity and everything, the water, and so it all plays out with everybody. And I think they're open to, anything that comes in that is beneficial with them, they're happy to embrace that.
As we wrap up, give me an example, a real world example, when you walked into a shop, you saw a problem that was related to pretreatment and cleaning, and you helped turn it around. Tell us what you saw and how you worked to fix that.
So I went to a customer. They were having visually the parts were not appealing, right? The metal was not sticking to parts. And of course, when they called the first problem, they said it was the plating mat. So they sent us pictures, and we can see, it was not consistent. The plating was not consistent. There was mixed plating in between. So we went to the shop, and the first thing we did was, we at the time that I went in, I was like, okay, yeah, it was a plating mat. We first things grab a sample on the line of the bat, test it. The batch was good. We're on wholesale in the lab. It looked fine on the wholesale, and it was at that point I know it was a cleaning issue, because if it plated fine on the wholesale, it's to say this is the wholesale. This was the same batch on the line. It wasn't a new makeup. Since the same batch you're running, it looks fine on the wholesale. Let's look at the cleaning. And when we went to the cleaning, there was a lot of oil on the cleaning, on the soap clean. There was a lot of oil. And, so when was the last time? Did you check? Did you change? When did you make this? But, and, the cleaning shop, they're kind of like, it's like a struggle making a new bat for them. They don't want to make a new bat. So at some point you have to, because if you had prevented this much residue in collection, we wouldn't be here. So they don't have a filter, they don't have anything on the bat, and there was so much, or you can tell on the bat. And there was a reason skip in between, the cleaning and the activation. So it was like coming out, it was rolling. It was basically getting like air dried before it get into the activation. So, with this, and I'm like, yeah, but I said, let's do something. We grab a hose, so clean in the line with the soap cleaner they have, do a little bit of resin, activate, then also plate on the plating bat. And it didn't look that well. So I said, compared to what we have in the lab and compared to what we have on the line, this is definitely a clinic problem. We have to change this bat. Oh, no, we don't want to change. Yeah, we're going to use this one. You have to. You're losing time. You're losing money. There's so much oil on this bat. I can't sieve it up. We gotta make a new cleaner. So they agreed, like, okay, we got to make a new cleaner. I said, once we're making a cleaner, you have to change your rinses. This water does not, you can tell, looking at it, it doesn't look good. And then they asked it active. I said, let's change everything new. Let's change it all new. And then we did. So we leave the plating pad. The plating pad is functional, is okay. We did some analysis. It looks fine. The concentration is good. But let's change the cleaning, the water, and the resin. And they did. And then they have a beautiful plating. I said, see, that's it.
Something you saw very quickly. But like you said, people are resistant to doing those type of things. But it makes all the difference, it seems like.
It does make a lot of difference, and it's like, yeah, we have to do it, And then let's. It's the root cause. That's what I see as a root cause. Let's get it out first, and if that doesn't work, then we can look into the plating bat. But I can tell you, the bat is good. The concentration is good. We don't have a lot of contaminants in the plating bats because we did the sample. There was some analysis done. So I said, let's looking at the cleaning. There's a lot of oil on this bat. Even if it cleans well, the oil is still going to stick back onto the pot because you don't have a filtration system in place that is taking all these residues and everything out of the bat. So we have to change it. And then they eventually did so.
Everybody's happy. Last question. What would be the one key piece of advice you'd give anyone who is running a plating line today about their pretreatment? What would be the thing you'd want to stick with them and stay with them, the one item?
One thing first is I'm going to tell them, I know it's a lot of work, but I promise if you take this into consideration, it's going to save you a long time of headache. Take quality control serious. Take quality control serious in terms of checking your bats every day. I know they say, we don't have that time. They just want to start. No, if you don't check, if you don't know what's in there, then you're setting up yourself for like a plating failure. We have to know what's in there before we start plating. Right, check your water, check your soap clean, check your plating bat. Make sure everything is in the plating, like in the right parameters for your operation before you begin production. It's a little bit of time consuming, but it saves you the production downtime, overtime, things like that. And also, again, you can have the best chemistry, but if you don't have the base, you're gonna end up making more scrap than you should have. You're losing water. You're losing time,
and you could lose a customer if you're not really watching that.
You don't want to keep your customers waiting. So, in order for everybody to be happy, let's do our check. Let's do the basic things. It's like a rush process. Let's do it. Don't overlook it. You can overlook it, but I promise that's the most important part of plating. If you don't have a clean part, you will not have a clean chemistry, you will not have a clean production. Because the more you keep doing, you're dragging stuff from, the cleaners to the activate to the back end. You end up crashing the bat itself because you've dragged so much in that you shouldn't have. So ensure you have proper cleaning, ensure you have proper rinsing, and, the rest would be history.
Bukola, I appreciate your time. That's been great information, and I hope we can get you back soon. Thank you very much for joining us.
Thank you so much, Tim.
Thanks for listening to Seen and Solved by Hubbard-Hall. For more episodes, visit hubbardhall.com or wherever you get your podcasts. Be sure to like and subscribe, rate and review, and join us on social media. Produced by Awcast.